In this figure, we are going to be learning lesson 10.2, which is about similar figures. Our objective is I will describe properties of similar figures and describe a sequence of rigid motions and dilations that show similarity between figures. Okay. From the digits clip that we watched about similar figures, we know that a figure is similar to another figure if you can map one figure to another by a sequence of rotations, reflections, translations, and dilations. Okay, and a similar figure is different than similar figures are different than congruent figures, because remember, congruent figures are figures that stay the same shape and size. That would be if you rotate the figure, reflect, or translate. But similar figures, let's write this down, are the same shape but are different sizes. So let's write that. Similar figures are the same shape but are different sizes, okay? Because the similar figures involve dilations. They involve rotations, reflections, translations, and dilations. Whereas, like I said, congruent figures only involve rotations, reflections, and translations. Because when you rotate, reflect, or translate a figure, it stays the same size and shape. But when you dilate a figure, it either makes the image figure bigger or smaller. Okay, so similar figures are the same shape, but not necessarily the same size. Okay. All right, now we want to see that, or we want to know what the symbol is for is similar to. This, it's like the little squiggly sign. This means is similar to. Okay, this means is similar to. It's just the squiggly line. Whereas remember the congruent, the symbol for congruent is it's an equal sign with a little squiggly sign. Okay, so let's look at example number 1. It says, if triangle MNO is similar, there's the symbol, is similar to triangle PQO, then answer the following. The angles in triangle MNO are taken to what angles in triangle PQO? Okay, and here's our two figures here. We have MNO and then PQO. All right, so obviously these figures aren't congruent because they're not the same size, but they are telling us that they are similar. Okay, so they have the same shape, but they're not the same size. So the way we figure out what angles from triangle MNO are taken to what angles in triangle PQO, it's very important that we look at the order of the letters in both triangles. Okay, so when you have two figures now, it's not MNO and then M prime, N prime, O prime. Now there might be completely different letters. Okay, so here's how you figure out which angles map to which angles. You look at the order of what they say the triangles are. See how M is the first letter in our triangle here? That means that M corresponds with point P, because point P is the first letter in this triangle. Point N corresponds with point Q, because they're both the second letter when we're reading the triangle. And then point O corresponds with point O, right? Because they have a point in common. If you look over here at the figures, they have a point in common. Okay, so if you look at the angles, same thing. The lineup tells you, the lineup of letters in your triangle tells you a lot about what angles are taken to what angles. Meaning corresponding angles. Okay, so angle M, it's the first letter in our triangle. Angle M right here corresponds with angle P because that's the first letter in this triangle. So these two angles are actually the same angle measure, angle M and angle P. So angle M maps to angle P, which means, so what that means is angle M is congruent to angle P, meaning they have the same angle measure. Okay. Now let's look, the second letter in this triangle is N. So angle N maps to angle Q because that's the second letter in this lineup, angle Q. So what that means is angle N is congruent to angle Q, meaning they have the same angle measure. Congruent means they have the same angle measure. Lastly, angle O in MNO, so this angle right here corresponds with this angle in PQO. So this is the same angle measure. Okay. Angle O from MNO maps to angle O here, which means that angle O is congruent to angle O. Right? They're both the third letter. All right, so this, what we're talking about, these are all corresponding angles. And they have equal angle measure. Okay, so whatever angle N is, whatever the measure of that is, which it looks like right here, the way it lines up with the coordinate plane, this is a 90-degree angle, it's corresponding with angle Q, which is also a 90-degree angle. You could see it lines up with the grid lines. They are corresponding angles. They have equal angle measure. They're both 90 degrees. Angle M corresponds with angle P. They have the same angle measure. Okay. How are line segments in triangle MNO taken to the line segments in triangle PQO? Well, again, the order here of the letters tells you a lot about what the line segments correspond with. Okay, we're looking for corresponding sides to figure out the line segments. So we need to find corresponding sides between our figures. Okay, so it says MN are the first two letters in this triangle and PQ are the first two letters, which means that side MN corresponds with side PQ. Okay, these map to each other because they're both the first two letters in our triangle. So MN, side MN maps to side PQ. Okay, that line over top of the letters means it's a line. All right, let's see. The next side here we have NO. Well, NO are the last two letters in our triangle, which means NO corresponds with QO because these are the last two letters. So side NO corresponds with QO right here. Side NO corresponds with QO. And then lastly, we need one more side of this triangle here and where it corresponds to, where it maps to. MO, if you notice, M is the first letter, O is the third letter, which means MO corresponds with PO, which is our last side of our triangle. Okay, so like I said, the order of the letters shows you exactly how the sides correspond, how the angles correspond. So we could say side MO corresponds to PO. Okay, so the last thing we need to do is, how are these, remember, this is obviously dilated, right? You're going from, it's saying that triangle MNO is similar to triangle PQO, okay? So, really what we're doing here is we're trying to, it's being dilated. It's obviously an enlargement. It's going from here to here. This figure is larger. So we have to figure out how are the line segments corresponding. We need to find the ratio. Remember, the ratio, okay, of the scale factor is the image side length over the original side length. Okay? So in this case, here the image is the second figure, because it's the second figure in our example it's similar to. So we have to figure out how is PQ corresponding to MN. What's the ratio? Well, it would be PQ over MN, right? Because it's the second figure over the first figure, the second figure of the first figure, side length. Well, PQ here is 1, 2, 3 units long, so it's 3 over. And then MN is 1, 2 units long, so it's 3 halves, okay? We'll check it. Let's do a check to see, because if these figures are similar, then the scale factor is going to be the same. So let's check QO over NO, right? We're taking QO and we're checking the ratio of it to side length NO. So we're trying to figure out how does QO correspond with NO. Well, QO is 1, 2, 3, 4, 5, 6 units long, and then NO is 1, 2, 3, 4. Well, if you reduce 6 over 4, it's 3 halves. Okay, so the scale factor here is 3 halves. The line segments, we showed how they were taken based on the lineup in the triangles, and then we got the scale factor by putting the image side length over the original side length. Okay, now try the got it number 1, and then watch the video.